Hello. Yeah, I have a lot of departments we work in. This is all just built around, it's all a bioanalytical development group. So we started off, we are a bioanalysis group at heart, even though we support all these other functions. So today we're going to talk about really three main things. One, where we started with E-Workbook and how it has grown since then and how we use it on a regular day basis, and some new things that we've done kind of tying in our different departments together so we can better collaborate, all within the E-Workbook ecosystem. So to go back in time, way back when, we started evaluating ELNs back in 2016. The issues that we were having back then were our bioanalysis group. We had our processes, our paper processes have evolved to a point where they're pretty much all digital anyway, but they're all piecemeal kind of applications and nothing was really joined together. So it was a natural fit to evolve into an ELN. And we worked together and we evaluated a bunch, and E-Workbook came into mind, mostly because one thing, out of all the processes and manual processes that we had, our reagent management process was the most tedious, and it was already at a digital point where we built an Access database that stored all that information. But it kind of sat there and it was really inefficient, tedious, and reagent management in general is just terrible, right? You gotta deal with aliquots, labeling tubes, all these things. It's just the worst. But at the same time, it's really the most important thing that we do. Everything that we do in the lab is reagents, equipment, samples, that's it. That's the basic thing. And it just turns out the inventory, those are the three main pillars in inventory, right? So it was kind of a natural fit. We started the implementation process in 2018, and at that time we also got reorged into drug discovery. So our idea of having using E-Workbook at the time as a reagent management system evolved to, well, now drug discovery wants to use the ELN portion of it too. But we held strong with what we wanted to do. And so we continued on with that reagent first mentality, even with the pivot. And so everything was geared around reagent management. And it is the foundation of how we operate. It's a foundation of many labs operate, and it's something that even drug discovery would benefit from as well. So let's take a look. In 2021, we pivoted to the cloud. So it was an on-prem web implementation. 2021, we moved to the cloud. That was pretty seamless, to be honest with you. We were all set up to do this. But when we talk about E-Workbook, we really talk about 4 core modules. Obviously, there's E-Workbook, but inventory was a huge part of it. And we use Advanced to kind of glue everything together. It kind of ties the whole experience together. And then recently, we've implemented Request in there, and we'll talk about that towards the end. I'm going to make it through the whole slide deck. I got a lot to talk about, so bear with me here. The inventory system is really the key. It's our bridge between the digital world and the physical world, right? So we can, with inventory, we can create our reagents, but then we can print labels, barcode them, and then that barcode is what bridges us together and allows us to do our physical laboratory work, but in a computer, like at the benchtop. So every benchtop has a computer or a docking station that you can operate. So we're not doing anything paper. Then we use Advanced as well. Advanced does interact with the barcode labeling process as well, but we use that to actually physically execute what we're doing, our tasks at the bench, and we also use it to integrate with some laboratory equipment. The one thing is, especially with the reagent management portion implemented, we didn't want the ELN portion to just be a file repository where you're just dumping PDFs and Excel files or anything. We have this system, it has a lot of capabilities. Why can't we have it kind of go along with the workflow have it do work for us, so it's less burden on the scientist at the bench. And so that's the core philosophy with our instance. You can use it as a data repository too, but that's not our focus. So let's talk about reagent registration. This is the first templates that we ever built in there are based off of getting reagents in there. Equipment's pretty straightforward. Samples is pretty straightforward. Reagents takes a little bit of nuance to get it done. And one of the things with inventory, I don't know how many people here have inventory. Raise hands. Okay, that's not bad. That's not bad. The thing is, when you have inventory, it's a separate module, so it's a separate web browser, right? And so when you're in the mix of things at the bench, you don't want to be clicking all over the place. You want to do everything in one spot. So that's where Advanced really comes in and is our helper in this. We have reagent registration templates that can reside within your experiment, so you can go along with the flow of creating something and register them into inventory. Our whole facility is mapped out in inventory with from the building down to the labs to the equipment. Everything is in there. So inventory is a digital map, essentially, of our physical building, which is great. So you can just find things, register them in there, then straight from one spot, we can print our labels out and go. There's no pause. You're always working, you're always getting things through, which is really helpful. Now this template, we can do more than one reagent at a time, multiple reagent types. We have over 30 reagent types, and so it gets unwieldy, but the templates really help guide you through this and make it simple, easy, and intuitive to go through the process. But then you still actually have to do the work. You still have to generate aliquots, aliquot them out, and put them in there. So the reagent registration portion in the ELN, we took a process that took 5-10 minutes, and now it's a minute or two to just get things in there. But then that's just the digital portion. You still have to label all your aliquots, then you got to fill all your aliquots, and you got to put them in storage. And that is the tedious part. Well, we can make it easier by using integrating our equipment in with the ELN. So we have a tube labeler that we have integrated directly in with inventory. So when you print that label, it sends it to the tube labeler. You put your tubes on the deck and you hit go, and it'll just go and label the tubes. This is one of my least favorite things to do, but it does it now for me. It's so good at it now that when I get back to work on Wednesday, I'm going to label 5,000 vials of reference standard, and I'll get it done just me in a day or two. So that's amazing. I don't have to do any of that. Then we also have liquid handlers that can do the filling for us. And so this workflow, now this is a small representation of it, but when you scale it up to 5,000, you can really see how this can benefit you. And usually this would take like a team of people to do. I don't need that. I can just do it myself. So now it takes the burden off of everybody else. Everybody else can continue on with their work, which is great. So we're decapping and capping, filling, everything all on deck, no human intervention. It just does it, and I can go and do something else, which is great. Really easy to work with. So that's an example of that instrument integration portion of it, and how we use the ELN, we use inventory, and we use advanced all together to work as one to really make something complex simple and not tedious anymore, right? So this starts getting you thinking, like, what else can we do with this? Now, that is pretty straightforward, right? There's not a lot of intermediate work being done. You're not planning an assay, you're not doing calculations of dependencies, but we want to leverage these tools that we pay for to their fullest extent, right? So we want to maybe take this into other real bench work. That was all set up, reagent set up. Now the reagents are stored. How are we going to use those reagents in our regular daily assay activities? And sometimes in the past, when we built out these workflows and we made templates, they're really rigid, and you can only do one thing. And then if something happens at the bench, you're stuck, right? Then you have to pull out of that template, then do some manual explanation of what you have to do, and it breaks the workflow up. We don't want to do that anymore. So when we started thinking about doing these complex workflows, we want the template not to dictate what the work that we do. We want to dictate to the template what we do. And that's a huge paradigm shift for us. And it started to expand our capabilities greatly when we changed that mindset. When you are able to pivot like that, it takes away the cognitive load from the scientists. So now they're just focusing on the work that they're doing. They can pivot, the template's there, and they'll work with it. And we do have automation capabilities, but you don't always want to do everything on a robot. Maybe it's just something small, and you can just do it by hand. If we have those situations, the template shouldn't dictate that. You should dictate to the template what you want to do. So it should be interchangeable, and that's what we're building now. With that in place, we're cutting down our times like dramatically. So something that would take 2-3 days to plan and execute, now we can do in a single day. It would take maybe 10 minutes to plan, 20 minutes to prep, and let it all go. It's so easy now. So now we can do more in a work week than we ever could before. So in order to explain how we could do this, I'm going to get a little sciencey, all right? So bear with me here. Some of our drugs that we work with are ADCs. A lot of people work with ADCs. And I've focused a lot of my time on the biotransformation of our ADCs in circulation. Now, in ADC, you have an antibody, a linker, and a payload. So typically, your antibody targets a tumor internalizes the whole structure, cleaves off that payload at the end, and that payload will kill the tumor cell. It's great. The problem is that sometimes in circulation, that payload can get cleaved off in circulation. So we need to account for that. We call those metabolites in our world. And we usually do this metabolite analysis on LCMS. Everybody does it. If you do ADCs, this is free payload is standard analysis in there. But what we have found is that there's other metabolites that can form in circulation. Specifically, the linker payload structure can get cleaved in circulation, and they can get released. And then after that, they can react with glutathiones, cysteines, and albumin, and can become whole new drug analytes, right? These are very important, and we want to account for this as well. Now, when we look at most of these metabolites, them, just like the free payload, they can get cleared out of your system in 30 minutes. But the albumin is very interesting. If it does conjugate with albumin in circulation, now that structure can remain in circulation for a week or two. And so that's a very important metabolite that we want to keep track of. There is a problem with this, and everybody knows that this can occur at low levels, and most people acknowledge it, but they don't really monitor it. And there's a reason for that. It's really hard to monitor all those metabolites. It's really complicated. One of the things is that it's a very low abundance, so you need a very sensitive assay to do that. And most of our LCMS methods aren't sensitive enough to measure that. And another thing is you need a lot of sample volume to do that kind of analysis. So we thought we'd take a different approach, and we'd do it by ligand binding assays. I have a reagent set that can measure something as small as 1.375 kilodaltons, which I'm very proud of. Usually, typically, ligand binding assays, you're looking at 5 kilodaltons or higher. You know, that's usually the realm of a ligand binding assay, but we're pushing some limits here with this. There are some caveats still. We can get the sensitivity on a ligand binding assay, but we would have to do some sample pre-processing before we can run it in any of these assays. Specifically, we got to remove all the ADC out there and just have the metabolites left in the sample in order to do this. So that's pretty challenging in itself. So let's go to the ligand binding assays first, and then we'll go into that immunodepletion to get rid of the ADC. So we are not a large group, so there's not a lot of hands on deck. So we leverage technology to do a lot of our work with us. And so you like the Gyre Lab platform to do a lot of our ligand binding assay work. It's a semi-automated platform, and that's the part that we like the most about it. It runs a sandwich ELISA just like anything else, except it does it on its own. All you have to do, and why it's called semi-automated platform and not fully automated platform, is you got to do all the prep work ahead of time. So you got to create your working stocks, you got to make your standard curve, you got to dilute your quality controls, you got to dilute your unknowns, make your capture texture reagent, put it on a PCR plate. Well, you got to spin it down and then put it on a PCR plate, and then give it to the gyros, and then it'll execute the assay steps for you. And so when it executes the assay steps, it does the same thing as you would do on a plate-based ELISA, except it does it on a CD. If we got an older group, and we know what CDs are. It'll use a CD and run the same assay at a nanoliter scale. So because it's done at a saw scale, we can get great sensitivity out of it. And also, a typical ELISA usually runs 4 to 6 hours. This can do that in 50 minutes. So now we get a lot of time in there. So now we're making it really efficient, right? So using this, we developed 2 methods. One, a total linker payload assay that can measure all the different metabolites I showed earlier, all in one assay. And then the second one is specifically on the albumin, because like I said, albumin is the one that we want to really monitor, because that could be the one that is circulating for a long time and may do damage. We got the sensitivity that we're looking for on the GyroLab platform, and it's these assays are really good. The only caveat is that we got to get rid of all the circulating ADC first out of this. And this is where the immunodepletion comes in. And so for this, and now you're starting to see why people don't monitor this all that much. Obviously, LCMS is one thing, but now even in the ligand binding assay, there's a lot of pre-processing that has to be done to these samples before you go. We use a magnetic bead system that has streptavidin encoded magnetic beads. We take an anti-ID antibody that's biotinylated, immobilize it, you wash, then you add your sample, you wash, and then you take the supernatant, and that just has all your free metabolites with all of your ADC extracted out of this. That's a lot of steps. And this is just, for example, this is just one sample. If you're running clinical samples, you're doing hundreds at a time. This is going to be unwieldy. It's not scalable for this. And so this is a big roadblock here. The sample tracking, you're going to have a new tube for each step here, right? So there's a lot of tubes working around. It just becomes too complicated to do. And you're working with clinical samples, you got to document every single step. So now you do a step, then you got to stop, you got to document it, then you got to go and document. And it gets crazily complicated, and a lot of mistakes can happen. So we have a lot of things that we need to work with here. So then when you put it all together, you have to do all the immunodepletion steps. Then you got to prep all this for 2 separate assays and run it on the gyros. And I say we prep it for 2 different assays because we're using the gyros platform, we can do the one sample and split it off into 2 assays at the same time. So now you have one diluted sample, you get really good consistency off of that. You get 2 separate readouts out of it, which is good. It's still a lot of bench time work here, and you're doing multiple assays, multiple immunodepletions. It's a lot going on here. So even if you use technology, you still have roadblocks. So we took a step back, and we have E-Workbook, we have a robot, we have all this equipment, but they're all kind of isolated. What if we build a unified workflow that ties everything together? We have an automation system that can accommodate all these, and we could even do this manually, or part of it manually in a hybrid approach, and part of it automated. All of these kind of things. We want to be flexible for anything that is thrown at us. So let's knock out the immunodepletion first. This one is relatively simple. We took that immunodepletion step, we eliminated all the manual process. We used a Kingfisher Apex. It could do 96 samples at one time, which is great. And it increases our efficiency, obviously, from 1 to 96, which is in itself there. But because it handles everything all on its own, we can increase our efficiency of our immunodepletion, make it more reproducible, and we can get great 99.8% ADC depletion on that, which is great. And at the end, it documents all the steps with it. So it's great. It gives us a report Everything that it did, it documents. So it knocks out a bunch of problems that we were having in there. And you still have to do the front end. So we have an advanced spreadsheet in the front end that we can document all of our preps. And because all of our reagents are in inventory, it's just a barcode scan in there. It runs all the calculations, does everything for you. So now something that was not really possible or feasible to scale up, we have a scalable workflow. So that's great. So now let's go back to the assays. And now we have my robot, my Hamilton Vantage. It's my baby. We've been together for a very long time. I think I got it 2014 is when we started our journey together. And it is a workhorse. It works every day for me. I don't get a lot of time in the lab, so it does a lot of what I do in the lab for me, which is fantastic. And I'll get to that in a second. So we configured this just to be a benchtop analyst. This has all the tools that a benchtop analyst has at their disposal at the bench, all integrated in there, including the centrifuge to spin down the samples for a gyros assay, plate washer for plate-based assays. It has that decapper you saw earlier that will decap and cap reagents or samples. It does all of that. Plate shakers, it has a great seesaw module, which holds a 60 mil trough, and you can spike reagents in there, and it'll mix it for you, which is great. So it's all hands off. Once you load it, it goes, and I don't have to do it. And it has this great track gripper arm that moves things all over the place for you, all on deck, above, underneath, everything. So it does everything. The problem with this guy is that it's just a liquid handler until you link it up with things, right? You need to integrate this in with your ecosystem for it to be able to work like a benchtop analyst. So we'll go through the workflow then. This is where E-Workbook falls in this whole big scheme, right? In the gyros, it needs to tell us where it wants its samples to go so it knows and it can execute all the assay steps for you. So it'll tell you the location on that PCR plate it wants, or the volume it has, the dilution scheme that the samples need to be diluted. It gives you all the information that me as a benchtop analyst would need to know to execute this. Well, we take that and we plop it into an advanced spreadsheet, right? And all that same information goes in there. We have the dilution scheme hard-coded in, so all you have to do is import that load list in there, and boom, now we can get going. So now we have to do all that front-end work for the gyros, right? We got to make our stocks, got to make the standards, we got to do all these things. But we have inventory on our side to help us through this. So inventory, since all of our reagents are in inventory, all it is a barcode scan away. We can go in, we can scan in our material IDs right in there, pull up the information, then the spreadsheet does all the calculations for us. We don't have to do anything. Even we can make working stocks that are just used for that assay. It's in the lower section there. And it'll do all the calculations for you on that. It'll do unit conversions, all those great stuff. And you can choose the buffer and assign it the buffer so it knows, so we can build the associations. Same thing with standards. It's going to search your load lists from the gyros, and it's going to identify what standard curves need to be prepped. So we're doing 2 in this example. And so we can build that association. This is how we're going to prep this standard curve. This is how we're going to prep that one. And then it'll do all the calculations and take your working stock and dilute it down just how you want it to do. Same thing with capture detection reagents. Barcode scan it in there and assign it to whatever the load list capture detection reagents are. And then it'll do the calculation for you. Just a barcode scan away. Real simple. QCs are a little bit more complicated because you might want to make them fresh one day, you might have them frozen stock in another. Well, this is built to accommodate both situations. You can dilute, you can pick some working stock that you or the robot made, or it's frozen already and you just scan in the barcode in there. It pulls the dilution scheme from the load list, so everything's already there. There's no manual transcription needed. It's just scanning away at this point. And then you select the buffer and it goes. So all of this stuff I've been talking about, it doesn't really matter if you're doing this by hand or if you're using a robot. You're doing it no matter what. You got to plan this run for whatever application you're going to do. If you choose to do it by hand, well, we have a nice clean view for the bench. So the benchtop analyst only sees what they need to see. They can execute, and it's clean. If you choose to go robotics, well, then we have a robotics view too. So the street in the background, it took all that information that we did all along this journey, and it then plats it in there. It tells you where you need to put all those reagent stocks that you say you're going to use. It's going to give it to you. We're going to put it on a reagent plate, so this is what it is. It's an empty vial if you want the robot to make it for you. So you just got to put a vial on there so it can do its thing. The different views are really for what the scientist likes to see or what needs to see. Then we also have that seesaw module where you're going to put some buffers on there, an Epidorf carrier. So these are all volume-based decisions that you have to make. You might need more than 1.5 mils of buffer to do this, so then you use the seesaw module. If you have less, you can use an Epidorf carrier, and if it's even less than that, you can use a reagent carrier. That's it. It's very simple, straightforward. And then in the background, the spreadsheet essentially takes that loading list from the gyros and it appends all the pipetting instructions all to it. So it's all the same thing. It's more like a snowball effect than it is piecemealing things together. It's just taking what it has and we're just adding to it along the way. So we're not really manipulating anything, we're just adding to it, which is really great. So the other part of this, and it was touched in the very beginning, is that we do manage our inventory as we go along as well. So the spreadsheet's also going to go and see how much of all the reagents that we use, and we can decrement that from our stock in inventory. So we can keep track of the usage of each aliquot, and obviously we can check what that aliquot, what experiments it was used in. All that stuff is all done within one place. You don't have to click around anymore. And it goes in a flow. So you just go from one step to the next, and one step to the next. And because you're doing this all in real time, you can pivot whenever you need to. Say you need another working stock that you didn't think of. Well, you just add it in there, and it'll just add it in there. And then you just go, and it makes it really easy. So this is like the whole through workflow. This is actually a real qualification run we did for those linker payload and albumin assays. And this is, because it is, now we took that template and we templated it again to a batch record. And so now everything is all done. All right, I'm doing good on time too. So here we go. Thank you. So all the analyst needs to do at the end of the day is just scan barcodes in. I guess it's kind of boring when you think about it, but it's a good thing. There's less opportunity for mistakes at the bench, right? You're just following it through. There's checks in there, so it will alert you if you do something wrong as well at multiple steps into the process, which is really helpful as well. But the focus is now not on, am I documenting things right? The focus is solely on, am I doing my work properly? Am I doing the right thing? And you're taking that cognitive load off of the scientists where they can focus on the actual work and not, all the other stuff that's going on in the world. So now went through the process. We did the spreadsheet work. Now we get to the robot. The robot pulls those instructions, and it's going to show you the same things that the spreadsheet showed you there. The difference is now you're in front of the robot. You're not in front of E-Workbook anymore, right? But the correlation is the same. They're telling you the same thing. You load the things up there. It doesn't even trust you at this point. It's going to barcode scan in all that stuff, make sure that you put it in the right spot, and then it'll go, and it executes. So this is all hands off. I'm not even here. I was actually at my desk and I just left my phone recording this. I was in a meeting while this was going on. I just set it and forget it. But it has a centrifuge in there. It spun down samples, gives me that last PCR plate. I do have to come in the lab, seal it up, and put it on the gyros to run. So all I have to do is really barcode scan and seal a plate and run it. Like, that's it. That's great, right? So that's great. So in this qualification that we showed, This is a hybrid qualification, so we could do it manually, we could do it automated. That's great. 2 and 5 are the robot. The other ones are done by 2 other analysts. They're all the same. It's interchangeable. So there's no difference when you run it on the robot than compared to that. It's whatever you need to do to execute a run, you can just go. You can go robot, you can go manual. It is what it is. So that is the case study. All right, so I got through that part. Now we're going to home stretch here. So now that's just me at the bench top, right? And that just is my little micro environment that I work in. But that's not how we operate in our group or in our building. We have a lot of interdepartmental collaboration. A great example of that is protein purification. So say I, as an end user, I want to have a protein made, and I got to contact another department, the cell line development group. I have to fill out a Word document, email it to them, and then they go and grow the cell line, collect the supernatant, submit the supernatant to a purification group purifies it, and then gives it to me, right? All of this involves multiple emails, and the emails never have enough information. So then you have to have a meeting about and then you have to have a meeting about the meeting and about the emails, and it just goes over and over. And we still end up not getting all the information through there. There's got to be a better way to do this. How can we communicate better interdepartmentally as well? So we have all these advanced spreadsheets for each group, right? And they work, but we need to tie them together, and that's where request comes in. And this is something that we just started working on this year, so this is relatively new to us. So if you guys have better ways to do it, please let me know. I will steal your idea. But this is kind of the workflow that we're thinking of, right? So we already have that advanced inventory integration in there. We're going to use request as an overarching managerial layer on top of this. So each department still uses their spreadsheets, but then we can tie in request into those and then build linkages between advanced spreadsheets so we can have a constant flow of information through the whole process. So there's not a lot of retranscription of work done in there. So in here, we have grow cells, we got a template, we got collect supernatant doesn't really require a template, but then when we get to this, they need to register that supernatant so they can send it off to purification. And so this is where this requester template comes in. You could have that information already registered through the cell line, cell thaw and passage workflow that we have, or you can just register it direct from the request template. So you're in the flow of what you're doing, whatever fits that person at that moment in time, they have it and they can just go. Then they can register, they can add their labels, all the stuff that we talked about before is all in there. And then it pulls all that metadata, the sequence information, the plasmids that they use, the buffers, the media, all that stuff goes into the request template, right? And then they submit that request and it gets sent to the purification group. That purification group receives that request and selects that information, selects what jobs they want to do. And then all that information that the requester put in is then cascaded into the fulfiller template. So now that purified reagent is going to have all that metadata from earlier. There's no retranscription. It's all automatic, got put in. And so then when they select that job, now management likes this part. I'm really good on time now. So management can see how the work is, where it fits in with all the jobs, if they need to redistribute workloads, all of that's in there. So that we have that layer in there as well, which is really nice as well. But then purification group does their purification. They add in their additional information. So again, we're talking about that snowball effect. We're just adding on to this thing. We're building a story. Not only does that happen, but that supernatant is a different material than the purified reagent. But there's a parent-child relationship that's built in the background. So when we want to remake this reagent later on in the future, we can go back to this experiment, we can see where it came from, we can see maybe there's extra supernatant available, so you don't have to go through the whole growth process. You can just thaw out that supernatant and purify it. All of this is being captured all in the background. Then he can, whoever is doing the purification, they run the purification, register that all within the template, print the labels, aliquot, hand it off to me, put it in a freezer, do whatever it is. That's kind of the only communication outside of E-Workbook that's really necessary now. So that's kind of where we are now, and we're expanding on this. So we picked purification as the center point, and now we're building out request workflows out from there on both ends. And so now that's our tie-in for this overall workflow. So from a manufacturing standpoint, this is a big deal, right? So this is kind of the bioprocess workflow that you guys showed us a long, long time ago, but I think you moved on to bigger and greater things from there. So we kind of showed how inventory is, and always has been, really the key part of our E-Workbook experience. It captures all the important things that the benchtop scientist does. It puts it into a structured form so that everything that the benchtop scientist does within a template is structured data that goes into everything. So we can pull that out and work on anything. We have workflows that you can do manually, automated. The workflows don't dictate your work. We dictate the workflow to the templates, right? It really gives us a lot of flexibility when we're in the lab, and we're not rigid anymore. I showed you the metabolite stuff. I love that stuff, so you're going to have to hear me talk about it every time I give a presentation, probably. And can show you how we tie in automation into this. And the automation thing is a godsend for me. So thank you. I did it.
Yeah. So I think there's going to be a few questions. I'm just predicting this. We do have, I think, 3 or 4 minutes. Yep, so question over here. We can come to you next, Aristotle.
Yeah, thank you. Great presentation.
Thanks.
So for the results that you're generating on these samples, are you really storing them just within E-Workbook, or are you actually tying them back to the item in inventory and your results kind of living in there?
Raw data is stored in E-Workbook because that's our data repository essentially, but we use a LIMS system outside, and we're working on getting that better. I think we can do that. So the sample results aren't stored in, which sample management is only being done in inventory at the moment. It would be good, so in process for bioprocess, in process results, yeah, we have a template that does store that and handles all that.
So your raw data is living in the E-Workbook, and then you're just pretty much pushing it to the LIMS.
Yeah, for clinical samples, I think that's the right thing to do for this.
All right, thank you.
Yeah.
Okay, there's another question. Aristotle?
So I had a question on the payload multiplexes with the albumin.
Mm-hmm.
Is the payload still cytotoxic when it's attached to the albumin?
It can be, yes.
Okay.
It can be. But it's not now targeted only to the tumor. It can target anything. So in my use case with the Ribulin, that's actually a chemotherapeutic that's commercially available that we use as our payload. So we do have tox information on what it would look like in distribution, but yes, it could be active.
So does it have to come off the albumin to be active, or while it's on the albumin is the whole complex toxic?
I can't tell you. Yeah, no, it would have to still get cleaved to be active. Yeah, it would. But it can get cleaved through cathepsin in circulation. So it is still a possibility. The problem is the extended half-life, because it's conjugated albumin, it increases its exposure to be able to do that. And that's the concern that we have.